Hi, welcome to Sunil Maths tutorial, Fourier series, class number 7. In this video, we learn Fourier series for even and odd functions and we solve some problems. First, we learn even and odd functions. A function f of x is said to be even function if it satisfies the condition f of minus x is equals to f of x for all x. A function f of x is called even function if it satisfies this condition f of minus x is equals to f of x. F of minus x is equals to f of x for all the values of x. For example, suppose f of x is equals to x square. You see that f of minus 1 is equals to 1, f of minus 2 is equals to 4. So this function is f of x is equals to x square gives for negative values also you get same x square. So it means f of minus x is equals to f of x. So such function is known as even function. F of x is equals to x square is even. F of x is equals to cos x is also even. We know that because of cos of minus x is equals to cos x. So cos of minus x is equals to cos x. So f of x is equals to cos x, f of x is equals to x square. These are even functions. So let us see the definition of odd function. A function f of x is called odd function if it satisfies the condition f of minus x is equals to minus into f of x. For all x, f of minus x is equals to minus into f of x for all x, then we say that the function is odd function. For example, f of x is equals to x or x cube. So you can write f of minus 1, f of minus 1, minus 1, f of minus 2, you simply get minus 2 whole cube. So minus 8, minus 8. So this is nothing but minus f of x. So f of minus x is equals to f of minus x is equals to minus into f of x. Then we say that the function is odd function. You know sin x, f of x is equals to sin x and f of minus x is equals to sin of minus x. It can be written as a minus sin x. So this is nothing but minus f of x. So sin x is also an odd function. Sin x is also an odd function. So remember that. So f of x, I mean even and odd functions. Even function is also known as this even function is also known as symmetric function. This even function is also known as symmetric function. The odd function is also known as skew symmetric function. Odd function is also known as skew symmetric function. So I think you understand the both the definitions. Now let us learn one important point to remember. Any function f of x, any function f of x that can be written as arithmetic mean of, that can be written as arithmetic mean of even and odd functions. Any function can be written as the sum of arithmetic and the sum of means arithmetic mean of even and odd functions like this. F of x is equals to 1 by 2 f of x plus f of minus x plus 1 by 2 f of x minus f of minus x. So this one is known as even and this one is known as odd. So observe that. So every function can be written as sum of even and odd functions. And in case of integrals, you must remember a fact. Integral minus a to a f of x dx. One of the important property of integrals. Integral minus a to a f of x dx is equals to 0, 0 if the function f of x is odd function. If the function f of x is odd function. And 2 into integral 0 to a f of x dx if this function f of x is even function. So one of the important property of integration, integral minus a to plus a f of x dx is equals to 0 whenever this f of x is odd, and the same integral is equivalent to 2 into integral 0 to a f of x dx if f of x is even function. Now we go for Fourier series for even and odd functions. Before going to learn the Fourier series for even and odd functions, let us see Fourier series definition. Let us see Fourier series definition. So we know that any function f of x can be written as, I am writing the Fourier series definition in the interval minus pi to plus pi. In the interval minus pi to plus pi. So f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos nx plus summation n is equals to 1 to infinity bn sin nx. This is known as Fourier series expansion of the function f of x in the interval minus pi to pi, where you observe that this a naught is given by 1 by pi integral minus pi to pi f of x dx, and an is given by 1 by pi integral minus pi to plus pi f of x cos nx dx, and bn is given by the formula 1 by pi integral minus pi to pi f of x sin nx dx. So these are Euler coefficients, and this expansion is known as Fourier series expansion for the function f of x. Now we learn case 1 and case 2. In case 1 we take that f of x is even function. F of x is even. So if we take f of x is even, then this a naught can be written as 1 by pi integral minus pi to plus pi f of x dx can be written as 2 by pi integral 0 to pi f of x dx. So a naught becomes 2 by pi integral 0 to pi f of x dx whenever f of x is even. So in the similar case, we know that cos nx is also even. If cos nx is also even, then the product f of x into cos nx is also even. The product of two even functions is again even function. In this case, this an becomes 2 by pi. First I write general case and then I write even case. Integral 1 by pi integral minus pi to pi f of x cos nx dx. Here the integrand f of x into cos nx is an even function. So this an takes the form 2 by pi. Integral 0 to pi f of x cos nx dx. At the same time, sin nx is odd function. If sin nx is odd function, then the product f of x into sin nx is also an odd function. Remember that product of two even functions is even. Here f of x into cos nx is even because both are even functions. Here f of x is even, but sin nx is odd, but their product is odd function. If their product is odd function, then obviously the constant bn is equals to 1 by pi integral minus pi to pi f of x sin nx dx. This completely becomes 0 because this integrand is odd. The integral becomes 0. It means bn is equals to 0. Now see, a naught is equals to 2 by pi integral 0 to pi f of x dx. An is equals to 2 by pi integral 0 to pi f of x cos nx dx, and bn is equals to 0. If bn is equals to 0, then obviously the Fourier series takes the form f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity an cos nx, where a naught is equals to 2 by pi 2 by pi integral 0 to pi f of x dx, and an is equals to 2 by pi integral 0 to pi f of x cos nx dx. This is known as Fourier series expansion for the even function. This is known as Fourier series expansion, Fourier series for even function. Fourier series for even function. Remember that in case of even function, Bn is always equivalent to 0. This is case 1. This is case 1 whenever f of x is even. We go for case 2 whenever f of x is odd. Let us take case 2, and this function f of x is odd function. This function f of x is odd function. If remember that if f of x is an odd function, then a naught is equals to 1 by pi integral minus pi to pi f of x dx is obviously becomes 0 because this integrand is odd. This integrand is odd and limits are same limits with opposite sign. This one is minus, this one is plus. Minus pi to plus pi. So f of x dx integrand becomes 0. And a naught value is 0. Therefore a naught is equals to 0. Next, we know that this cos nx is even. Cos nx is even. And f of x is odd. The product of these two, f of x into cos nx, is also odd. Already we see that the product of one even and odd function is always an odd function. So f of x cos nx is odd, then this an is equals to 1 by pi integral minus pi to pi f of x cos nx dx is obviously 0 because this integrand is 0. F of x cos nx integrand, the function f of x into cos nx is an odd function, obviously this integral becomes 0. It means an also 0. A naught 0, an 0. Now what happens with bn? Sin nx is odd function, and f of x is also odd function. So this term is well defined, bn is well defined. So this bn is equals to 1 by pi integral minus pi to pi f of x sin nx dx. You get 1 by pi, 2 by pi integral 0 to pi f of x sin nx dx. Remember that here the integrand f of x into sin nx is an even function. F of x into sin nx is an even function. I'm sorry. This is not an even function. This is an odd function. No. This is very right. Sin nx is odd and f of x is also odd. The product of these two, odd into odd, integrand is even function. So whenever this integrand is even function, you see the property here, property of this integral. F of x is an even function, then you get 2 integral 0 to a f of x dx. So whenever the integrand is even, that integral is well defined. So here also this integrand is even. So we are right. This integrand is even. That's why it can be written as 2 by pi integral 0 to pi f of x sin nx dx. So here you remember one basic concept. The product of odd and even. The product of odd and odd function and odd function gives an even function. So here in this case you observe that a naught is equals to 0, an is equals to 0, but bn have some value. So the Fourier series takes the form f of x is equals to summation n is equals to 1 to infinity bn sin nx, bn sin nx, where this bn is equals to 2 by pi integral 0 to pi f of x sin nx dx. This is known as Fourier series for odd function. Fourier series for odd function. And here it is known as Fourier series for even function. Fourier series for even function. And here this one is known as Fourier series for generalized, all Fourier series for generalized function f of x. So remember that. This is the introduction part of this video. In this video, we solve one or two problems, depends upon this odd and even nature. So let us see the first problem. Find Fourier series. This is the question. Find Fourier series for the function f of x is equals to x in the interval minus pi to pi. In the interval minus pi to pi. So here f of x is equals to x. Now you check it. F of minus x, what happens? Minus x. So you can write minus into f of x. So f of minus x is equals to minus f of x. This condition implies as the function f of x is odd function. The function f of x is odd function. If the function f of x is an odd function, in such a series, the Fourier series is given by, in such a case, the Fourier series is given by f of x is equals to summation n is equals to 1 to infinity bn sin nx, where this bn is equals to 2 by pi integral 0 to pi f of x sin nx dx. So you can substitute, which is equals to 2 by pi integral 0 to pi, the function is x sin nx dx. Use the Bernoulli's principle. 2 by pi x into integral sin nx minus cos nx by n minus of minus plus sin nx by n square and limit 0 to pi. You observe that sin 0 0, sin n pi is also 0. So this second term completely becomes 0. So you get the value for first one. 2 by pi, I am substituting the upper limit. Pi, I get minus, here it is minus, so minus pi cos n pi by n. And whenever you substitute the lower limit 0 here in place of x, so lower limit is also 0. This pi get cancelled. You get finally minus 2 by n cos n pi. What is cos n pi? Everybody knows that. Cos n pi is equals to minus 1 power n. So you simply write 2 by n minus 1 power n plus 1. Minus 1 power n plus 1. Therefore, the Fourier series is given by f of x is equals to summation n is equals to 1 to infinity bn sin nx, which is equals to summation n is equals to 1 to infinity 2 by n minus 1 power n plus 1 sin nx. This is the Fourier series for the given function f of x, which is required Fourier series for the given function f of x. In the interval minus pi to plus pi. So right, here in the Fourier series expansion f of x, if you substitute x equal to 0, obviously this series becomes 0. If x is equals to 0, then what happens? The above series completely becomes trivial. It becomes 0. Suppose if x is equals to pi by 2, then f of x is equals to also pi by 2, because f of x is equals to x, so f of x is equals to pi by 2. So now this Fourier series becomes pi by 2 is equals to summation n is equals to 1 to infinity summation n is equals to 1 to infinity 2 minus 1 power n plus 1 divided by n sin n pi by 2 sin n pi by 2. I replace the x by pi by 2, sin n pi by 2. If you remove the summation 2 into, if you remove the summation, you get simply 1 minus 1 by 3 plus 1 by 5 plus and so on, only you get even numbers, and the remaining for numbers pi, 2 pi, 3 pi, you get 0. So you simply get 1 minus 1 by 3 minus 1 by 5 minus 1 by 7 and so on. If you shift this 2 into this side, pi by 2, you simply get pi by 4 is equals to 1 minus 1 by 3 plus 1 by 5 minus and so on. This series is known as, this series has a name, Gregory series. Gregory, Gregory, Gregory series. This series is also known as Gregory series. So observe that in the next video we solve a bunch of problems, depends upon the odd and even nature. Keep learning. Wish you all the best.